Let's start with transport aircraft. So to figure out what goes into a transport aircraft, we need to know what a transport aircraft is. So what is a transport aircraft? If I ask you, before we even get to defining it, what would you consider a transport aircraft? Being big? Being big. Hauling cargo or passenger? A certain number of people? The regulations ultimately define it. Over 100, do you think? I heard a 19. That's an awfully odd number to pick. Okay, so so you're on the right track. So it's based on number of people or maximum weight, but it's defined by exclusion. So if I say defined by exclusion, what do you think that has to deal with? Something that's not a transport aircraft. Okay, so the regs, the FARs do specify what a non-transport aircraft is. They call it a normal category airplane. Okay, so here it's in 14 CFR Part 23, and it's and the specific regulation there is 23/2005, and that is certification of normal category airplanes. So I'm going to go ahead and pull that up, bring it over here where you can see it. Hopefully, it's freaking out a bit. There we go. Let's make this. Oops. And it did it on my laptop screen rather than the projector screen. Yeah, it's being what in the world there. Oh, now it's really being fun. Okay. Let's go out of here. This is what I'm trying to do, looking the wrong direction. Okay, there we go. So here's our CFR 14, and we're in part 23, and we want to see 23/2005. So it kind of starts with some kind of random stuff. I'm going to go to the table of contents so we can skip to it easier. So 23/2005 certification of normal category aircraft. So certification of normal category aircraft applies to airplanes with a passenger seating configuration of 19 or less, or I can drag this no. Oh boy. There we go. 19 passengers or less, or a max certificated takeoff weight of 19,000 pounds or less. So more than 19 passengers, more than 19,000 pounds. Okay, that's the cutoff. So that's for normal category. So most of what you've been learning about, most of what you've been working with, all the planes that are in our, in our tech ops lab, those are normal category aircraft. They're basically, the common term for it is general aviation aircraft. So that's what a transport aircraft is not. We go back to our slideshow. So anything that doesn't fall in this normal category, 19 passengers or less, or 19,000 pounds or less, falls under 14 CFR Part 25, and that is transport category airplanes. And if you open that one, hey, it worked this time. There is no kind of qualifier for size. I'm just going to pull up the table of contents for right now. But you can see there's applicability. If we look at that, prescribes airworthiness standards for the issue of type certificates and changes to those certificates for transport category airplanes. But it doesn't tell you what a transport category airplane is, right? And talks about who can apply for it. Special retroactive requirements. These were added because there were planes built before these regs came into effect. So the ones they typically cover are like the DC-3 and that kind of thing. But then they get into, this is moving really fast. Then they get into the actual aircraft itself. So there are regulations that govern like what the flight characteristics should be, what the weight limits are, center of gravity, what performance needs to be for things like acceleration and stopping, takeoff, landing, cruise speeds, handling, control and maneuverability, stability. You can see there's not, it really just gets into, if you're going to build a transport aircraft, these are what it has to be. It essentially creates a box that airplane has to fit in. And it includes characteristics for how it operates as well as how different systems, systems and structure. So it starts, here's like structure, flight loads, maneuvering, and further down it gets into the actual like different systems that the aircraft uses. Control systems, landing gear, personal and cargo accommodations, emergency equipment, right? So anything that is over 19,000 or 19,000 pounds max takeoff weight and over 19 passengers is going to have to comply with these regulations. Now there are different levels of regulation or different levels of compliance based on how big the aircraft is. Where is that here? There is some stuff in here, and it's spread throughout various subparts in here of, if an airplane has this many passengers, you got to have this kind of emergency equipment on board. Sometimes it's operational. If you're going to be operating over water for long distances, you got to do this or that. So, if it carries a certain amount of fuel, you have to be able to, you have to be, or if it weighs a certain amount, you have to get under a certain weight, max, basically you have to get under max landing weight before an emergency landing. How quickly can you do that? And if you're carrying too much fuel to do that, you have to have a way to dump the fuel. If you are able to just burn it off in a certain amount of time, you don't have to have a fuel dump system. So that kind of thing is laid out throughout all these regulations. To go through it all would be extremely time prohibitive. But we'll look at it as we go through the various systems during the course of the class. Okay. Now, in the transport category aircraft side, they are kind of broken down roughly, but not in such a manner that's strictly defined. But we typically have large transport category aircraft. This is what most people think of when they buy a ticket to fly somewhere. When you think of the big cargo airplanes, would be in a passenger configuration, because a lot of planes are either have a passenger option or they can be a cargo plane, right? But in a passenger configuration, they typically hold somewhere around 100 or more passengers. They're very complex. They have a lot of systems that have backups and redundancy in them. Those individual systems have backup and redundancy directly. They also have systems that can kind of take over from other systems if there's a failure. And then multiple turbofan engines nowadays. Back in the day, they would have had a turbojet engine, but those were quickly replaced with turbofan engines that are more economical. These can even be broken down into light versus heavy versus super heavy. Anyone have any idea what that is? If anyone's flown, they're probably somewhat familiar with this term. It's more of a term used when referring to pilot or for flying. Anyone ever heard the term heavy? An aircraft referred to as heavy? No idea. So what breaks this down oftentimes is the amount of wake turbulence that a plane produces. The wake turbulence or vortices. And so a plane that's referred to as heavy has a heavier wake turbulence, heavier tip vortices. And the result is smaller aircraft have to follow further behind. You have to have more horizontal separation between aircraft. You have to have more separation on the runway. Wait a longer period of time before a small plane can take off behind a larger aircraft that's a heavy. Most of the time, those are twin aisle aircraft. Except there are a few. The big notable one is the Boeing 757 is a single aisle aircraft, but it's referred to as heavy. Particularly the older versions that didn't have winglets, they gave off massive wingtip vortices. and have flipped quite a few commuter and personal airplanes that tried to take off too close behind them. And so they were given that kind of those designations. The super heavies start to get into the things like the double deck type airplanes, the Boeing 747 and the Airbus A380, which you're seeing a lot less of today. We've kind of gone away from those. Yeah. They're less affected by it. So typically, a heavy aircraft following a heavy aircraft is really not much of a concern. It's more if you're trying to follow if you have like an Airbus A320 trying to take off behind a 777, or a Cessna trying to take off behind any kind of an airliner, right? So a Cessna, GA Cessna, or even a small Citation, something like that is going to be prone to, disturbance from these wake turbulence and tip vortices. So. There's some smaller categories of transport aircraft as well. So we have regional jets, tend to be in the 40 to 100 passenger range. There's regional turboprops. They're still a transport aircraft, but they use a turboprop engine rather than a turbofan. Regional jets use a turbofan. Regional turboprop use a turboprop. They're in the 19 to 50 passenger range. And then you have your medium and large corporate aircraft, where oftentimes they don't necessarily carry more than 19 passengers, but they very often weigh more than 19,000 pounds when fully loaded at max takeoff weight. And so they fall into that category because of weight rather than because of the number of passengers on board. Even planes that are like the Beech 1900 is a 19 passenger airplane, but max takeoff weight is high enough that it has to be, it's a very small commuter turboprop, 19 passenger. But it falls in the transport aircraft range because it's over 19,000 pounds max takeoff weight. These are going to have similar or pretty much identical systems to the transport aircraft, large transport aircraft. As we saw with the regulations, 14 CFR Part 25, there are rules that govern how these planes have to be built, and they talk about every single system on the airplane, as well as the structure of the airplane. And so the manufacturers, whether it's a Boeing, whether it's an Airbus, whether it's a Bombardier / now Mitsubishi owns the regional jet program, whether it's Embraer, corporate jets and regional jets, whether it's Falcon, whether it's Dassault Falcon, Gulfstream, whoever, if they're building airplanes that fall into the transport category aircraft, the systems on them end up being very, very similar because they all have to work the same way. Not to mention they're all buying those from other vendors that they use the same vendor oftentimes. Okay? Boeing doesn't make all the parts on the Boeing aircraft. Airbus doesn't make all the parts of the aircraft. The names you hear, the Boeings, the Airbus, the Bombardiers, the Mitsubishis, the Embraers, they are basically buying a bunch of parts. Even the structures themselves, they're often outsourcing to third-party companies. They're the final assembler. That's about all they do. They buy engines from GE or from Pratt & Whitney or from Rolls-Royce, and they buy fuselage sections from these. There's all kinds of companies that make fuselage sections, and they buy air conditioning equipment from Liebherr, and they buy landing gear from Goodrich, and they slap it all together to create a Boeing aircraft or an Airbus aircraft. So because of that, the systems, whether you're working on one of these aircraft from any one of these manufacturers, the systems operate pretty much the same. They look the same. Some are bigger, some are smaller, right? Bigger airplanes, everything's going to be scaled up. But at the end of the day, an air cycle machine on a regional jet looks like a miniature version of the air cycle machine on a Boeing 777. The generator on a regional jet looks like the generator on a Boeing 777. It's just one I can pick up and carry around with some effort, 60 pounds. The other one I need a forklift to move around. Right? So, whoops, I didn't want to show you that yet. So what are systems? If I say aircraft systems, what are some of the systems? Oxygen, hydraulic, pressurization, fuel, fire detection and protection, landing gears a system, Ice and rain protection, flight controls. Here, how about I bring my list up now? The first page of like 3 or 4. APU, auxiliary power unit. Twin engine airplane actually has 3 turbine engines on it. Little tiny turbine engine. Pneumatic, which is like bleed air. Environmental control, this is getting into where you're saying oxygen pressurization and then temperature control. Those often are lumped into environmental control, but they're kind of separate too. You can look at them either way. Anti-ice, de-ice, rain control, electrical, fuel, hydraulic. Landing gear, I've got oxygen broken out, fire and detection protection, warning systems, communication, instruments, navigation, instruments being like flight instruments as well as system monitoring instruments, aircraft monitoring, potable water and waste, equipment, cooling, lightning system, lightning protection and static dissipation, power plants, emergency systems, interior and passenger. This list is not exhaustive by any means, but it gives you an idea of everything that goes into one of these aircraft. And then we have systems versus subsystems. If I ask what a subsystem is, what would you consider a subsystem? Give me an example where maybe we look at a subsystem. What do you think a subsystem is? Nothing? Tired today. This was a holiday weekend, right? So if I say environmental control system, we just kind of talked about that a little bit, right? So the example I have here, pack, which is an air cycle machine. So that this pack is made up of components: air cycle machine, heat exchangers, valves, ducts, water separator, right? That's a heat and cool, that's a cooling pack. Takes hot air, makes cold air. We have recirculation as part of that, fans, filters, duct work. And then we have to be able to sense and control it, right? To know, should we put warm air into the cabin? Should we put cold air into the cabin? Should we put warm air into the avionics bay? Should we put cold air into the avionics bay? Right? Now there's ice and rain. If I say ice and rain protection, what are some of the systems you know? You guys you studied this on smaller aircraft. What are the different areas that you would have subsystems of the ice and rain protection system? Wing leading edge, yeah. So wing de-ice or anti-ice. What else? What's that? Windshields. Propellers, if it's a propeller airplane. Engine inlets. These don't have carburetors. Pretty much all turbine engine. Can't think of it. Maybe like the DC-3s, you're getting old school. I guess they could have carb heat on a DC-3, but those are like grandfathered in. Most of those are being Basler turbo conversions. They're taking DC-3s and taking the piston engines off and putting turboprops on. So heated leading edges, thermal and pneumatic. Right. Most of what we're using on big aircraft are anti-ice. They're heated rather than boots, which are de-ice. The small turboprops and some of the small regional jets, they may have boots, but most of your bigger ones are going to blow hot air in, and the 787 is thermal electric rather than thermal pneumatic. Uses electrical elements to heat the wings. Heated probes. Pitot-static probes are kind of pitot probes. Static ports are pretty important, right? A couple airliners have crashed in the last decade or so because of icing on various probes or false indications. I think heated windshields. So, and then you also mentioned things like inlets and other stuff like that. How about fuel? If we break down the fuel system, what are some of the subsystems that would go into a fuel system? What does the fuel system have to do? We got to distribute fuel to the engines, to the users, engines and APU. The tanks are for a storage. So the pumps are kind of part of the distribution system. A dump system often is part of the distribution, but it can be its own. We talked about tanks and storage. Fuel indicating, you gotta know how much you have. You have an ATA list in front of you, don't you? We're kind of following the ATA codes here. So engine fuel feed, refuel, defuel, transfer, and dump. Sometimes refuel and transfer dump are separate, but you got to be able to get fuel into your tanks in the first place, right? You got to know how much is in there. And some of these are more integrated than others. Some of them, they're more discrete systems. Sometimes the refuel, defuel, transfer, and dump is tied into the fuel feed system. Sometimes they're totally separate. 727, they're mostly separate, but you can interconnect them to be able to move some fuel around, but only on the ground. You can't do it in flight. Okay. The other thing we have is systems are interdependent. So we've got systems and their subsystems, and then their components or the individual things like the fuel pumps you mentioned were a component in the various subsystems, fuel feed or fuel transfer. But when I say interdependent, what are we talking about there now? What is interdependency? Different systems are connected. Okay? Nothing runs in a vacuum, nothing works by itself. Everything on the airplane has some kind of an interplay going on. So systems run off of one another. What would run off to another? What are some idea? What would you expect to run off of something else? Nothing. Anti-ice, if it's thermoelectric, runs off the electrical system. Landing gear is going to be hydraulic. What's the hydraulic system run off? Essentially electric or engine. Ultimately, the engines are probably going to run both those things because they're, right? But what does the engine run off? Fuel, you got to get fuel to the engine. To get fuel to the engine, you often need electrical pumps. Some of them use mechanical Venturi pumps. So here's some example. Environmental control runs off pneumatic. Pneumatic is bleed air off the engines. Pneumatic's going to run off the engines or APU. The engines or APU run off the fuel. Fuel runs off electrical, or sometimes you have a fuel pump on the engine that's used to bring fuel to the engine. So if the engine's running, it's fueling itself. Electrical runs off the engines or APU. Hydraulic runs off the electrical and or the engines. Flight controls run off the hydraulics and or the electrical, right? And oftentimes on transport aircraft, these will run off multiple sources. It's not uncommon for a hydraulic system to have some pumps that are electric driven and some pumps that are driven directly off the engines. That's that redundancy and safety factor that comes into play. Okay. So we got to keep that in mind as we're thinking about like how the aircraft's operating. Right? There's a few reasons for it. One is just to understand the basic operation of the aircraft. You got to know what is feeding something. You know, you're not getting pressure in a hydraulic system. What could cause you to not get pressure in a hydraulic system? A leak. Okay, so the system could be leaking. What else? Clog. Actually, filter probably. What else? Think of interdependent. So you're looking at stuff just in the system, but remember, there's more that feeds into the hydraulics. Okay, the pump could be not working. Why could the pump not be working? The what? Electrical's not working, or the pump could be failed, right? It could be the pump itself, or it could be what's feeding the pump. What about indication? What if it's just a bad gauge? Is the gauge, or is it the wiring going to the gauge, or is it the sensor that's picking up the pressure to feed to that wire to that gauge? Right. This develops something as we're thinking through these items. We need to follow what's called the path of influence. When you take a troubleshooting class, we'll discuss that in more detail. But essentially, you got to kind of think back like this is the symptom. You know, the lack of pressure is the symptom. What are the causes? You know, what could cause it? Go back through what are all the things that, you know, from point A to point Z, what is B, C, D, E, F, G in the middle, right? And starting to eliminate or follow those. Right? So that interdependency is establishing that, you know, that relationship, that interdependency between various systems. So as we go through, as you're looking at these different systems, as we're learning about them, kind of keep that in mind. The other flip side to that is from the safety aspect of it, is if I'm going to turn something on, what is that going to operate? Right? We brought up hydraulics. You mentioned landing gear. If plane's on jacks, you flip on hydraulics. What do you think happens if someone left the gear handle in the up position and the gear are down? As soon as you turn on hydraulics, what's going to happen? Gear's going to come up. What happens if somebody's working in a wheel well? Not good, right? So you got to think about that. The other part that we're not going to be working on the gear, we don't have jacks, but when you flip on hydraulics, what else do the hydraulics run on a big airplane? The flaps and other flaps are part of the flight controls, right? Okay. Is anyone taking a look at the 727 out there, for instance? What happens to the flaps when it's just sitting out there? What do? They're drooped down. What happens to the elevator when it's just sitting out there? It's drooped down. What do you think happens as soon as you turn on hydraulic pressure? They all go back to streamline or they get sucked up. So if somebody's working in that area, good. Now hopefully whoever's working in that area has, basically gone and pulled the circuit breakers for hydraulics and put little red or yellow clips on them to prevent somebody from doing that. Or put a little sign, usually you do multiple things, on the hydraulic system switches so that someone doesn't turn them on. Okay? You got to think about it from both ends. But if you're going to go, again, flip a switch, move a flight control, move a handle, move a lever, what's going to happen on the other end? Not just on that system, but everything else that it ties to. Like, yeah, I'm going to flip the hydraulics on. It'll get a little bit loud. We'll make some pressure. Right? As long as no one's in the hydraulic bay, we're good to go. Except if somebody's out there doing wing rigging and now the flight control moves on them, right? Flight control rigging. So keep that in mind for safety as well as for things like troubleshooting and operation. Okay. Looking at some more things that play into transport aircraft is engine configurations. There's 5 common configurations we see in the United States. Okay. There are additional configurations you won't see very often. But the two that are probably most common nowadays are 2 wing or 2 tail mounted engines. Twin engine aircraft is what most newer transport aircraft are. Still somewhat recently, 3 engines, either 3 on the tail, like what our 727 outside has, or 3 split between 2 on the wings, 1 on the tail. Okay. And finally, the four engines on the wing configuration. Yes, there are some others. There's a 4 on the tail configuration that I think it was Aleutian did, Russian company, many years ago. Yeah, they had 4 engines, 2 on a pod on each side of the tail. So yes, there are more configurations, but these are the common ones that we'll see nowadays. With the two most common you're going to see are up here: 2 wing, 2 tail. Even the 3 and 4 engine aircraft are kind of going the way of the dinosaur. But if we look at them, they can be either a turbofan or a turboprop. Okay. If they're on the wings, turbofan, turbine engine driving a big fan, turboprop, turbine engine driving a propeller. Okay. 2 engines mounted on the tail, typically a pod on each side of the tail. Okay. Most common so here we've got our bigger airliners and then regional turboprops for the 2 on the wings. 2 on the tail is most common in corporate jets and in regional jet aircraft. Okay. That's a 67-seat aircraft. Okay. These here, that's a A350, holds a couple hundred people. That's a Q400-8, holds 50 people. That holds 67 people. 3 tail-mounted engines. Okay, your 727s. 2 on the wings, 1 on the tail. You've probably seen these before. You've probably never seen one of these in the top right. Okay. Bottom left here, and even I'm not 100% sure if this is a DC-10 or MD-11. Okay. They're derivatives of one another, 2 engine. The one on the top right is a Lockheed L-1011. It's Lockheed's last commercial airplane. Nearly bankrupt them, and they said, we're done with the commercial airplanes. We're just going to do military from here on out, and space program, space stuff. And then four wing mounted engines, 747. You even know what that is? Only single decker, so it's not the A380, it's an Airbus. Yeah. We'll get to it in a second. Airbus A340, again, another one that's not super common, but kind of going the way of the dinosaur. So, looking at the engine, at the aircraft themselves, what makes them up? So, kind of going historical age-wise, Boeing 727 is referred to as a narrow body. So, narrow versus wide body is in a passenger configuration the number of aisles that they would have. So, a narrow body is a single aisle, a wide body is a twin aisle. So, if you get in and there's one aisle down the middle, it's a narrow body, two aisles is twin. There is a wide body. Another name for these is a trijet, 3 engines trijet. These only had one engine configuration, the Pratt & Whitney JT8D. And these were a 3-crew aircraft. Who knows what the 3 crew members were? And I'm talking flight crew members. We're not talking about flight attendants here. Yep, pilot, first officer, and engineer. I heard navigator in there. Navigator was a 4-crew aircraft. So when you had back in the day before, so the first equipment or the first task that was automated on aircraft was the navigation side of it. And so that's where you went from a pilot or a captain, a first officer, a flight engineer, and a navigator. You dropped the navigator. So you went to a 3-crew aircraft. And then we automated the systems indication, the systems control. And that took us from a 3-crew to a 2-crew, where you have a pilot or a captain and a first officer. So this was a 3-crew aircraft. It always was a 3-crew aircraft. They never modified these to turn them into a 2-person aircraft. Some aircraft throughout their generations have gone one or the other. Big limiting factor on these was the engines. They could not change the JT8 because of this one back here mounted inside the tail. They couldn't fit anything else in there. And so there were various versions of the JT8, but ultimately they weren't efficient enough, and very ultimately they were too loud. This has hush kits on the back of it, just like the one we have outside. The original version of it didn't have this extra long piece of metal on the back. Okay. The Boeing 737, another narrow body. It's a twin jet. Now this was 2-crew, but because it was originally a fairly small airplane, so smaller transport aircraft could be built as a 2-crew aircraft initially. Okay, whereas larger ones needed that 3rd crew member. So originally these were a 2-crew aircraft because they were fairly small. This is big compared to the original. Look at some of the original 737s. They look really funny. They were nicknamed the Guppy because of how like short and squat looking they were. Twin jet, so 2 wing-mounted engines. Originally, it had the same engines as this airplane. Originally, it had the long, skinny JT8s, but they were later replaced with CFM 56 engines and nowadays CFM LEAP engines. CFM is a partnership. You'll see these. This is one of the most common transport engines out there today. Is a partnership between GE and a European company known as Snecma or Sanfran. It's a French company. Kind of neat the way they build these. GE, I got to look at my cheat sheet because I can never remember who builds exactly what. GE builds the high pressure compressor, the combustor, and the high pressure turbine. Safran builds the fan, the gearbox, the exhaust, and the low pressure turbine. And so what happens is, if these are also on, we'll get to Airbus in a little bit, these same engines are used on Airbus aircraft. If one of these CFM engines is going to be mounted to a Boeing aircraft, the parts that Safran makes get shipped to the United States, and they get mated into the final engine at the GE assembly plant, and then they get put on a Boeing aircraft. If they're going to go onto an Airbus aircraft, the GE parts get sent over to France, to the Safran factory, and they mate the parts together there, and then they go on to an Airbus aircraft. CFM LEAP, same thing. That's just the newer version of it. So GE final assembly is in Evandale, Ohio. Safran's is Villaroche, France. The 747 was Boeing's first wide body aircraft. in the commercial. Also the first double-decker aircraft. And the original version had a much smaller top deck. This is the 747-400, it's much bigger. But quad engine, Rolls-Royce RB211s were an engine option. GE, there was the older CF6 and now the newer GE Gen X. Pratt & Whitney originally did the JT9. That's the big engine that we have in the hangar. And now the new versions have the Pratt & Whitney 4000 on them, PW 4000. These were originally a 3-crew aircraft, the earlier models, and later models were adapted. They went to a glass cockpit, a computer display, and they were able to drop it to a 2-crew aircraft. That is just strictly piloting it. It doesn't have anything to do with duty times and that. Typically, there are more than 2 pilots on board a 747 because they're flying long enough distances that the crew members have to swap in order to get required rest. But it doesn't have anything to do with the operation. You can fly a 747 with 2 flight crew, as long as you don't time out. Nowadays, the older ones, again, you needed a flight engineer as well. The Boeing 757, 76, 67 were developed around the same time. What we have here is the 757 is a narrow body single aisle aircraft. The 767 was a wide body twin aisle aircraft. Both of these are twin engines. Both use the same families of engines. CF6, the Pratt & Whitney JT9, 2000, and PW 4000. The PW 2000, 757, PW 4000, and the 767, and the Rolls-Royce RB211. So you can see it uses similar engines to this, just only 2 of them because it's smaller aircraft. These were built originally. This was Boeing's first clean sheet design as a 2-crew aircraft. The funny part is in the 767, there's still a spot for a flight engineer panel because they didn't know if they would be able to certify it as a 2-crew aircraft. And that is a maintenance. Now it's more of a maintenance panel. There's a bunch of maintenance stuff on there, but you don't normally have a crew member sitting there. The Boeing 777, 7X is Boeing's largest twin engine aircraft. Still quite common being flown. Wide body, 2 aisles, twin engine. The 777, you had 3 different engine options, GE, Pratt & Whitney, or Rolls-Royce. The 777X uses the GE9X. This was the first Boeing aircraft to heavily incorporate fly-by-wire technology. Who knows what fly-by-wire is? Electrical and computers operating the flight controls rather than cables driving. And I say cables, but the cables are purely operating hydraulic valves on large aircraft. The cables do not actually move the flight controls directly on anything with more than about 50 passengers. If you don't have hydraulics, you basically cannot move your flight controls on something this size. Hydraulics are extremely redundant, but 2-crew certification from the get-go. Just to give you an idea of the size range of these things, here's a comparison of a Boeing 737 with a Boeing 777 in the background, showing the fact that the 777 engines are as big around as the fuselage of the 737. If you've never seen a 737 in person before, the 727 we have outside and the 737 share a common fuselage. So those engines are the same diameter as the 727 outside. So big, big, big engines. Okay. You're just waiting for me to say that, aren't you? Boeing's latest generation of aircraft, Boeing 787, which isn't that late of a generation. It's been flying around for a while now. Twin engine, wide body, 787. First all composite airframe. 2-crew aircraft. Glass cockpit, all that good stuff. What I was going to ask too, why have all these engine options? Why not just stick with one? It'd be a lot easier to design an aircraft that uses only one type of engine. Why have 3 different engine options on this one, or 2 different engine options on this one? Different what? To some extent, yes, but most of them are pretty competitive in terms of fuel efficiency and range and all that. What? Payload is pretty similar across the board. And there might be some slight differences, but Who makes the deals with the engine manufacturer? So Boeing doesn't make the deal with the engine manufacturer. It's the operator, the airlines. So if you already have a bunch of GE engines in your fleet, you'd probably go with the GE option, or at least it gives you some negotiating power. But typically what you'll see is if an operator, uses GE engines on their 777 and GE engines on their 757, they're probably going to operate GE engines on their 787s as well. There's some parts commonality, not a ton, but the big thing is you have a company you work with. The engines in airline world, or in transport aircraft world, are separate assets from the aircraft. It's not like your car or even like a Cessna or something like that. We played musical engines on the airplanes I worked on all the time. If a plane came in, needed engine work done, any kind of serious engine work done, it was not sitting on the ground while we worked on the engine. That engine came off, a different engine went on, airplane went out and flew, engine went to the back shop to be overhauled, taken apart, that kind of thing. We're constantly changing engines. Our engines, some of them were owned by us, some of them were leased. Some of them, we didn't even buy engines. We bought what's called power by the hour, which is thrust for a certain number of hours, and GE or Pratt & Whitney or whoever just supplies engines until you reach that. Obviously maintaining them to a certain level. Our engine shop was a GE power by the hour certified repair shop in-house, even though it was our own repair shop in-house. So that's why you'll see these multiple. On some of the smaller aircraft, typically there's only one option because it's not as big of a deal. But the big aircraft, there's almost always multiple options. Moving into a different manufacturer, Airbus, the A319 through 321 family. The A320 was the first of these to come out. Then they made a smaller one, the 319, a larger one, the 321s, with variants all between. Narrow body, twin engine. We talked about the CFM engines. They also have a Pratt & Whitney. And then they have an IAE engine option. And this is a joint venture. IAE is between Pratt & Whitney in the United States, Rolls-Royce in England, Japanese Aero Engines Corporation in Japan, of course, and MTU Aero Engines in Germany. So you got 4 different engine companies. Pratt & Whitney makes the combustor and high-pressure turbine. Rolls-Royce makes the high-pressure compressor. Japan Aero Engines makes the low-pressure compressor, and MTU out of Germany makes the low-pressure turbine. And they all get mated together. I have no idea where they're put together for what airplane or whatnot, but so yet another one. This was the first truly certified from the factory fly-by-wire aircraft. These use the Airbus side stick control rather than a yoke in the middle. Okay. 2 crew aircraft. Direct competitor 737. Airbus A330, A340. This is an A340 that you see here. A330 is a twin engine. Both of them are wide body, 2 aisles, whether you have a 4-engine or 2-engine version. Different engine options. You can see a lot of them are repeats from other aircraft, 2 crew. And you won't see too many of the A340s anymore. They're being retired. Airbus's newest aircraft, the A350. It's a wide body twin engine. Yes, I did skip one in there. Wide body twin engine uses the Rolls-Royce Trent XWB. This is Rolls-Royce's kind of direct, this is Airbus's direct competitor to the 787. It's a little bit bigger, but it's also a composite airliner, 2 crew. You saw this one earlier. And then getting into the really big one from Airbus, although these are kind of going away. They're one of the shortest lived transport aircraft out there. They're being scrapped and they're only like 15 years old. A380 wide body, full double deck, quad engine, but still 2 crew with relief pilots. A couple others you'll see here and there. McDonnell Douglas, MD-10, MD-11, DC-10. Today, most of them are flown by cargo operators. In the United States, that's the only operators that fly these, FedEx and UPS. They can hold a ton of weight. These are great cargo airplanes. This is that tri-jet configuration with 2 wing-mounted engines and 1 tail-mounted engine. Originally 3 crew aircraft, nowadays modern versions, and even the old ones that have been retrofit and updated are a 2 crew aircraft. So they've proved them, or they've been worth enough that it's made sense to put whole new flight decks in them that allow them to become recertified as a two-crew aircraft, even in the older versions, the older ones. Moving into the little bit smaller aircraft, medium and large, Airbus A220 was originally built by Bombardier as the C series and bought by Airbus as part of a kind of a trade embargo or tariff run around and to kind of stick it to Boeing, so to speak. But it's kind of an interesting story. If you ever watch some of the documentaries on it, I think it is. I don't, maybe not. But if you want to know like aircraft manufacturer business and kind of the cutthroat business of selling airplanes. But narrow body twin engine, this uses the Pratt Whitney PW1500G. Anyone know what the G means in the end there on those engines? You're seeing G designations in a lot of turbine engines. So this was one of the first aircraft that came out with a geared turbofan, which means there's a gearbox between the low pressure section and the fan, almost like a turboprop. More efficiency. This was two crew. This is probably one of the most technologically advanced airplanes out there today, even though it's not one of the biggest. They made these are super high tech. Similar market, a little bit smaller, similar market. In this case, Embraer E19195, narrow body, large regional, small, mainline type aircraft, twin engine. And these originally used the GE CF34, but now the newer versions of them use the Pratt Whitney 1900G, another geared turbofan engine, two crew, fairly high tech, not quite as high tech as the A220, but pretty close. Embraer 170, 175, these are common in regional service in the United States. Narrow body, twin engine. They also have a version, the older version with a standard engine, newer version with a geared turbofan engine. Okay, the CF34, is anyone in here military? Anyone do anything in Air Force? Oh, okay. The TF34, you might have heard of a TF34 as the engine used on the A-10 Warthog. So it's a common derivative of that engine. The CRJ family, originally built by Bombardier, now it's supported by Mitsubishi Heavy Industries. CRJ 200, 700, 900, narrow body, single aisle, twin engine, GE CF34, various iterations of it. Two crew. The 550 I keep separate. It's technically a 700. So originally these had 50 seats in all coach. The 70 could have 70 seats in all coach, but typically it was run with first in coach, a mix. 900 could have 90 all coach, or about 76 mix of first and coach. The 550 is a 70-seat airplane that only has 55 seats in it. It was a kind of a variant. It's mainly a naming convention or a marketing convention. Competitor to that, Embraer 135, 140, 145, another narrow body, twin engine, single aisle. Uses Rolls-Royce, small Rolls-Royce engines, two crew. This is getting into the size where it's almost got systems are kind of a mix between bigger aircraft and small aircraft. So everything up until this, including this airplane, uses hydraulic fluid, uses Skydraw. When you get into this, it's a 5606. It uses the red fluid. Okay. Everything up to this point is AC. They use AC current for electrical. This uses DC. It's 24-volt DC, just like your smaller airplanes. So there's some getting to the point where they swap over. And then we start to get into the regional turboprops. So Embraer. Anyone know where Embraer is out of, by the way? How many of you have even heard of Embraer? They're more common than you think. Like I said, these are common in regional airlines. These are common in regional airlines. Anyone know where Embraer is out of? I'll give you a hint. The nickname of this plane is the Brasilia. It's Brazil. Yeah, they're out of Brazil. Okay. You'll hear people refer to them as jungle jets sometimes. So, but the EMB 120 twin engine turboprop, Pratt Whitney 118 A's and B's. Most of what you see flying around today is a B model. Two crew, single aisle. Saab out of Sweden made the Saab 340 and the Saab 2000. The Saab 2000, they lost their shirts on it and it bankrupted Saab Aerospace. So the Saab 340 was a common regional turboprop. They're still flying around. You still see these down the Caribbean and the areas like that. Twin engine. They use a GE CT7, which is technically a turboshaft engine that they stuffed the propeller on the end of. Two crew aircraft. And then the smallest of the transport aircraft that are used in commercial service, Beech 1900, 19 passenger, narrow body twin engine. This uses a large PT6, which is the same type of engine that's in like the King Air that we have. It uses a much larger version of the PT6. They make PT6s in all different sizes. Two crew. This is basically a King Air that's been blown up bigger. We took a King Air and made it bigger, and every time they made it bigger, the flight characteristics got really funky, and so they had to fix the aerodynamics, and so to fix the aerodynamics, they added a little fin somewhere. It's got fin. Every one of these, if you ever get the pleasure of working on one of these, every one of those fins has a de-ice boot on it. In addition to the tail, the horizontal, the vertical, the wings, and then every one of these little fins has de-ice boots on them. So I haven't had the distinct pleasure of working on them. I don't think I ever want to, but I had some friends who worked on them, and they said they were a nightmare for keeping the de-ice boots working correctly. They were always replacing them. Anyone ever changed a de-ice boot? I wish we had time and a way to do that as a project. What's that? You got to peel it off, and then you got to get all the adhesive off that's left behind because it's got to be a perfectly clean surface. That's probably the worst part, is getting rid of all the stuck-on adhesive. And then when you put the new one on, it's like you got to make sure there's no bubbles under it. It's basically a big sticker. You got to make sure there's no bubbles under it. That's straight. You don't want your de-ice boot like going at a funky angle, right? So, anyways, lots of de-ice boots, PT6 engines, 19 passengers. The last airline I knew of that flew these, I think, went bankrupt, but there might still be some little regional, like local operators here and there. So you still see them around. There were a lot of them operating out of Denver at one point. So that's kind of the quick rundown of transport aircraft.